Hi there, it's Professor Shannon Gracie back with you. We're using Robert Blitzer's combo text, the Introductory and Intermediate Algebra for college students. And here we go. We're now going to learn about slope. When we're done with our homework, we should be able to compute a line slope and use slope to show that lines are parallel or perpendicular or neither, and then calculate rate of change in applied situations. So let's go ahead and warm up. Whoops. So pause the movie and graph these equations. Alrighty, let's see how you did. With this one, notice that we have one variable, so that means that we're either going to have a horizontal or a vertical line. So let's isolate this y variable by adding 2 to both sides, and then we get y is equal to positive 2. So that is the graph. That means that y is always positive 2 no matter what value x takes on. So we'll have our standard scale. So y equals 2 will be up here, and we'll make our horizontal line, and we're done. How'd you do? Great. Okay. Next up, let's go ahead and graph this one using intercepts. So again, we'll just kind of cross this out, and we'll let x equal 0, and this will get us the which intercept? Good, the y-intercept. So then we'll have negative 2 times 0 minus 3y equals 9. So that would zero out. That would give us negative 3y equals 9 with an end result of y equals negative 3. So we get our ordered pair of 0, negative 3. Now I'll go ahead and let y equal 0 for the next one. This will get us our x-intercept. So then we'll get negative 2x is 9. So x will be negative 9 halves. So we get negative 9 halves, comma 0. And then our checkpoint. Let's, I don't know, why don't we let x equal 3. I'm just making it up. I thought that might work out well. And here we go. We'll have negative 6 minus 3y's equals 9. So then when I add 6 to both sides, I'll get negative 3y is equal to 15. So then we'll have y is equal to negative 5. So we end up for our checkpoint with the ordered pair 3, negative 5. So here is all of our stuff matched up. Okay, so now we can go ahead and make our picture. So don't forget to name your axes. And we'll have the standard scale, I think, will work well. So x and y. And we'll go ahead and plot our points, and we'll keep our fingers crossed that we don't get a triangle. So here we go. 0, negative 3, the y-intercept is here. And then negative 9 halves is about negative 4 1/2. So 1, 2, 3, 4.5. And then our checkpoint, 3, -5, is here. And it's looking good. No triangles here. So let's make our picture of that goes with the name. And we're all set. How'd you do? Awesome. All right, so next up, we'll get started on slope. All right, the slope of a line. Mathematicians have developed a useful measure of the steepness of a line called the slope of the line. Slope compares the vertical change, the rise, to the horizontal change, the run, when moving from one fixed point to another along the line. So the official definition for slope is as follows. The slope of the line through the distinct points x sub 1, comma y sub 1 and x sub 2, comma y sub 2 is, we'll go through it a bit, the change in y over the change in x, which is equal to rise over run. So in Mathese, what you get is m equals y2 minus y1 divided by x2 minus, x1. So let's see what, a picture of that would look like. So let's make just an axis. Where here's our x and here's our y. And then we can pick our, points to be anywhere. Why don't we have our first ordered pair, let's put it here. And so this would be x1, and this would be y1. And then our second order pair, why don't we put somewhere over here? And this would give us our x2, and up here would be y2. And then if we draw the line between these 2 points, what happens is you can make a little slope triangle like so. Right? And so to get that ratio of rise to run, do you see that over here, what's this amount? I mean, if y2 was 5 and y1 was 1, what would you do to figure out that distance? Good, you'd just do 5 minus 1. So similarly, this amount is y2 minus y1. And then for the change in x, it works the same. We'll have x2 minus x1. And that's where that comes from. Okay. And this ordered pair up here was, of course, x2 comma y2. And then this ordered pair down here was x1 comma y1. Alrighty. So here we go. There's a caveat, of course. x2 minus x1 cannot equal to 0. If this is the case, you're going to end up with a vertical line, and vertical lines have slopes which are undefined. It is common to use the letter m, as we used above, to represent the slope of a line. Now, I don't know about you, but I had no idea why we used the letter m. So I found out that this letter is used because it is the first letter of the French verb monter, meaning to rise or to ascend. So I thought that was pretty cool. But I'm a math geek, so you may not feel the same. All right, here we go. Example 1. Find the slope of the line passing through each pair of points. So I'll help you out with the first one, and then we'll leave the second one to you. So my advice is to write the general formula each time you do one of these problems until you have it memorized. So m is equal to y2 minus y1 all over x2 minus x1. So we might as well have this be our x1, y1, and this can be our x2, y2. So m is equal to negative 6 minus 4 over 3 minus negative 1. And I got those values from, how we set it up above. And coming up here, m equals negative 10 over 4. And we can reduce that to be m equals negative 5 halves. And we're done. So go ahead and pause the movie and go and do part B. On your mark, get set, go. All right, here we are in part B. We'll check your work. So again, we'll have this be x1, y1, and this guy will be x2, comma y2. So the slope will be 7 minus 3 halves. Now be careful, I was suckering you into this problem. The fractions aren't going to go together. You're going to have to get, least common denominators and crunch through it. That's just how it worked out. So negative 5 halves minus 8 is our denominator. So here, if we adjust the fraction as so, we will get m equals 14 minus 3 all over 2. And then we'll have, let's see, negative 5 minus 16 all over 2. Which will give us, let's see, 14 minus 3 is 11 over 2. And that's all over negative 21 over 2. And then we can invert and multiply. So the 2's will divide out. And at the end of the day, we will get negative 11/21. Now, if you got that one, you had your Wheaties today, because that one had all that fraction business going on. Okay. So example 2, what we're doing is we're going to use this graph to see if we can figure out what the slope is. Now the best way is to use, 2 points that end up exactly on a corner. So for example, we wouldn't want to use this point over here because remember it's like roughly 1.8. But these look good, right? Because they corner on integers. So let's check it out. Remember that we're looking here at rise over run. So as we move from left to right, this one actually falls, doesn't it? So it's going to go down 1, 2, 3 units. So it went down 3 units from 5, and which way does it go now? Does it go right or left? Good, it goes right by 1 unit. From 0. So we go back over here. So down 3 units means, so remember, M is change in Y. We're going to use this concept of it over change in X. So we said that it went down 3. So isn't that negative 3? And it went right 1. So at the end of the day, the slope is negative 3. Now, you could have just used those ordered pairs if you wanted, right? That would be another way to do this problem. You could have used the ordered pair 0, 5 and the ordered pair 1, 2, and then used our slope formula and got the same result. Okay, so here are the different possibilities for a line slope. You can have a positive slope. So let's go ahead and Y. And actually, if you don't mind, I'm going to just copy that little picture that we made. All right. All right, close enough. So here we go. We've got, if you have a positive slope, your M is going to be, your slope will be greater than 0, because that's mathese for positive, right? So it is, as you're moving from left to right on the x-axis, if you trace along the line, you'll be going uphill. As you move from left to right, you're going uphill. So something like this would be a positive slope. And notice as we move from left to right, and if we were to make a slope triangle, we'd be going to the right and then up. Anywhere we are on the line, we go to the right and then up. Now, negative slope means that M would be less than 0, which is mathese for negative number. So we would have, as we move from left to right, we would be going downhill. So if you went from left to right, you're going down the hill. Okay? All right, a 0 slope. So if M is equal to 0, we will have a horizontal line because there's no rise. You see that? There's no rise. So your y2 minus your y1 would 0 out, right? Now an undefined slope happens when you always have the same x value. So that means that x2 minus x1 is 0, which would make the denominator 0. So vertical lines have a slope which is undefined. Okay? How are we doing? You hanging in there? All right. So let's go to our next set of materials. Slope and parallel lines. Two non-intersecting lines that lie in the same plane are parallel. If two lines do not intersect, the ratio of the vertical change to the horizontal change is the same for each line. Because two parallel lines have the same steepness, they must have the same what? Good, they must have the same slope. Okay, so here we go. Here's a couple of items. If two non-vertical lines are parallel, then they have the same slope. So that's a clue. You're like a math detective here. If two distinct non-vertical lines have the same slope, then they must be what? Awesome, parallel. Two distinct vertical lines, each with undefined slope, must also be parallel. Okay? Now, slope and perpendicular lines. Two lines that intersect at a right angle, so a 90-degree angle, are said to be perpendicular. If two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two lines is -1, then the lines are perpendicular. So again, there's some more clues for you. Now, another way of saying the product of the slopes is -1 is by saying that perpendicular lines have slopes which are negative reciprocals of each other. So whichever way works the best for you, whichever way to think about it, you should use. And then thirdly, a horizontal line having what kind of slope? Good, 0 slope is perpendicular to a vertical line having what kind of slope? Awesome, undefined slope. So let's next example. Determine whether the lines through each pair of points are parallel, perpendicular, or neither. So what you have to do is you have to crunch out the work. You have to get the slope for each pair of points that are on those lines, and then you have to use the information that we just discussed to decide if they are, parallel, perpendicular, or neither. So here we go. Let's do like slope 1. Slope 1 will be these points, right? So slope 1 will be -3, actually, minus negative 15 over 0 minus negative 2. So the first slope will be, I believe that'll be negative 12 over 2. So that first slope will be, oh, actually, do you guys see it would be negative 3 plus 15, so that'll be positive 12. So that first slope will be positive 6. All right, well, this one will be the second slope, so M2 will be 3 minus 6 over 6 minus negative 12. This will give us negative 3 over 6 plus 12 is 18. So this will be negative 1/6. Okay. Then you start to reason. Okay. The lines are not parallel, since the slopes aren't the same. 6 is certainly not equal to negative 1/6 unless you hit the margaritas before this movie, right? All right. Now, this is what we check. Is M1 times M2, is that equal to negative 1? Well, M1 we got 6. M2 we got negative 1/6. Is that equal to negative 1? Negative 1 equals negative 1, right? So therefore, the lines are perpendicular. Now, if neither one, if you hadn't gotten either case, then the lines would have been neither, right? Okay, so go ahead and pause the movie and you try part B and part C and see how you do. All right, let's see how you did. Again, we'll have this be the first one, so M1 is equal to 13 minus negative 7 over 3 minus negative 2. M1 is, that'd be 13 plus 7, so we would get 20 over 5. So M1 equals 4. This will be the second one. So M2 is 15 minus negative 9 over 5 minus negative 1. M2 equals 24 over 6. M2 equals 4. So we do our check. Okay. Is M1 equal to M2? Well, 4 equals 4. So yes. So the lines are what? Good, parallel. All right, so here we go. This will be our first one. So M1 equals negative 5 minus negative 11 over 0 minus negative 1. M1 equals, that would be negative 5 plus 11, which is positive 6, over positive 1. So M1 equals 6. The second, for the second set of points, we'll have M2 is equal to negative 6 minus negative 8 over 12 minus 0. So M2 will be positive 2 over 12, and we'll get a result of positive 1, 6. So then keep our colors consistent, is M1 equal to M2? No, because 6 is not equal to 1, 6, so not parallel. Is M1 times M2 equal to negative 1? Well, we've got 6 times 1, 6. 6 times 1, 6. Is that equal to negative 1? 1 is not equal to negative 1, so not perpendicular. So, what do we say? Neither. All right? So last up is our application. So here we go. Construction laws are very specific when it comes to access ramps for the disabled. Every vertical rise of 1 foot requires a horizontal run of 12 feet. What is the grade of such a ramp? Round to the nearest tenth of a percent. So here we go. We've got rise over run is equal to, so what was the rise? Good, vertical rise of 1 foot. So that would be 1. And it requires a horizontal run of 12 feet. So we would put 12 for the run. Right. So you've got a ramp that's going to look something like, you've got, this would be 1 foot. And this would be 12 feet. And then the ramp, would go like this. Right? All right, so we've got rise over run is 1/12. So the grade is 1/12. Now we've got to manipulate 1/12 a bit. If we divide 1 by 12 on the calculator, right, because we want to get this into percentage land, and they said it was okay to round. So 1/12 is approximately 0.083. And to get that to be a percentage, right, 0.083 times 100% is equal to 8.3%. So now let's give our result in words. The grade of the ramp is approximately 8.3%.